Hi there, Physics 152. My name's Jason Harlow. I want to give you a quick introduction to what's going on in your third week of practicals, which is February 1st to 4th. So first of all, there's a quiz on Thursday. So we are going to be spending a little more time than usual on the tutorial section of practicals, and your TA is going to be helping you go through some of the mastering physics problems. Now, as for the activities, ordinarily we do something a little hands-on, some sort of experiment or measurement, but this week we're just going to be focusing on mathematical methods in physics. And in particular, I want to talk to you about approximations. Now, right now, Professor Kushner might be talking about electric fields and the electric field of a dipole and how you can approximate that. That's an approximation. In relativity, when you have time dilation, there can be an approximation for that. In a pendulum, when you're considering the torque on a pendulum, there's something called the small angle approximation. Approximations come up so often in physics, and they're all based on one mathematical concept, and that's called the Taylor series. So, what's a Taylor series? Let's find out. So, it turns out that any function can be expressed as an infinite sum of terms that are expressed in terms of the function's derivatives at that point. If you know all of a function's derivatives at x equals 0, for example, then f of x equals f at 0 plus x times the first derivative of f at 0 plus x squared over 2 times the second derivative of f at 0 plus x cubed over 3 factorial times the third derivative of f at 0, etc., plus etc., etc. So let's do an example. Consider the function f equals, let's say, 1 over 1 minus x squared cubed. So what if you know that x is very small, and you'd like to have a simpler function to see how much this differs from 1. You know, if x equals 0, then this is 1 over 1, and it's 1. But how much different is it from 1? Well, let's do a Taylor series. So, f of x equals 1 minus x squared to the power minus 3. So if you evaluate that function at 0, you get 1. What about the first derivative? Well, the first derivative of this function, you do d by dx of 1 minus x squared to the minus 3. So the way you do that, chain rule, so the first thing you do is you take minus 3 times that function, 1 minus x squared, to the power minus 4. You subtract 1 from the exponent. Then you multiply by the derivative of what's inside. So that's going to be derivative of 1 is 0. Derivative of minus x squared is negative 2x. So just simplifying that, negative 2x times negative 3 is plus 6x times 1 minus x squared to the minus 4. That's the first derivative of x. If you evaluate that at 0, then the first derivative of the function at 0 is 0. The x is 0, so 6 times 0 times 1 minus 0 to the minus 4 is just 0. Okay. Now, let's do the second derivative. Second derivative will be the derivative of this function f prime of x. So the derivative of that. Now, you have two things, so we're going to use the product rule. The way you do the derivative of a product is f double prime x is equal to d by dx of the first thing times the second thing plus the first thing times d by dx of the second thing. Okay, so d by dx of 6x is just 6 times the first thing, 1 minus x squared to the minus 4. Plus minus 6, so it's plus 6x times minus 4. The minus 4 comes down and becomes a minus 24x times 1 minus x squared to the minus 5. You subtract 1 from the exponent. And don't forget to multiply by what's the derivative of what's inside for the chain rule, which is minus 2x. So this 2 and this x comes out. You get f double prime x is equal to 6 times 1 minus x squared to the minus 4 plus 48 x squared times 1 minus x squared to the minus 5. Now all we need is for what that is at 0. F double prime at 0 is going to be 6 times 1 minus 0, so that's 6, plus 48 times 0 squared, so that's all going to be 0. It doesn't matter what it is. F double prime at 0 equals 6. So what we've got here is the first derivatives are 1, 0, and 6. So if we do Taylor series, f of x equals f of 0 plus x times f prime at 0 plus x squared over 2 plus times f double prime at 0 plus terms of order x cubed. It's just equal to 1 plus x times 0 plus x squared over 2 times 6. So this function, 1 over 1 minus x squared to the minus 3, is approximately equal to 1 plus 3x squared. This is a good approximation when x is much, much less than 1, since then x cubed will be much, much less than x squared. And x to the 4th will be even less than that. All these higher order terms disappear when you know that this x is very small. So you can just use 1 plus 3x squared, and it can be really, really handy. So in today's lab, we're going to be first just going over some things about Taylor expansion. That's activity 1. Activity 2 is looking at the Lorentz factor in special relativity. This gamma equals 1 over the square root of 1 minus v squared over c squared. You can make a nice little approximation of that using a Taylor series. Activity 3 is the simple pendulum, and so then we'll actually be looking at what the torque is and looking at the small angle approximation and how sine theta becomes theta. Why does that happen? And activity 4 is back to what you're doing in class right now, electric field of a dipole, and how if you go on axis, it's approximately equal to or proportional to 1 over r cubed. And you can figure out why that is, again, from a Taylor series. So last thing is, you're going to be doing a lot of math in this week's practical. So my recommendation is to do what I did and to do it on paper. I have a little notebook and I have an actual pen and paper. This is how mathematicians do math. They write things out. You're going to have to be doing that with your friends and then sharing your paper. So what you need is a fast way of taking pictures of whatever you've done and then uploading it to your Google so that your friends can see it. You can each upload your math, look at it, compare the math, delete the ones that you don't want to keep the ones that you want to keep, and submit to your TA. Lots and lots of photos. So if you don't know how to upload photos quickly to your Google Slides, you should maybe do a little research, search around for what's the best way to do that using your phone. So good luck. I hope you have fun, and definitely good luck on the quiz on Thursday.